Welcome to our symposium on motion and emotion in developmental disorders, a spherical perspective, a spherical psychophysiological perspective. My name is Tal Dotan Ben Susan. I'm the director of the Research Institute for Neuroscience Education and Didactics of Fondazione Patrizio Paoletti. So the aim of our symposium is to enlarge the dialogue between neuroscientific findings related to neurodevelopmental disorders, together with a clinical and theoretical perspective, which emphasizes that in addition to the cognitive deficits in developmental disorders, there are also motor and emotional aspects which should be taken into consideration. We will combine both contemplative neuroscientific knowledge together with cognitive developmental psychology and embodied theories of cognition. Mentioning also the sphere model of consciousness by Patrizio Paoletti, which was recently considered the most advanced theory of consciousness. I will start with my presentation on timing, emotion, developmental disorders in the view of the sphere model. So we will start with an example of dyslexia, taking into consideration the three vectors of bodily deficits, emotional deficits, and cognitive deficits. So the cognitive deficits of dyslexia are well known, related to fluent word recognition, poor spelling, poor decoding abilities, and reading abilities. The emotional and motor deficits are less acknowledged, but they are prevalent. So from the emotional aspect, for example, lack of self-esteem, coping abilities, and the large number of depression reported in dyslexia. And from the motor aspect, we know that there are many deficits and many times they are combined. Let us take a small example from an interview conducted with one of our participants who suffers from dyslexia. So he said, "My balance is not so good naturally, so it may have improved following a certain training, which we will soon mention. There were times I got confused and it bothered me because I felt stupid. In the beginning, I was angry at myself. Now think passing life feeling stupid because you're clumsy or because you have some deficits." What we will see throughout the symposium also is different approaches to what causes what. Here we will focus more on the motor aspect and especially on the cerebellum, which is traditionally acknowledged in motor control and coordination, but it is increasingly being recognized also as an important factor for sensory regulation, also for emotional regulation and cognition. As it acts as a timing mechanisms for both sensory, cognitive, and emotional processes. So our first hypothesis was, if dyslexic participants suffer from a cerebellar deficit, which is in line with the cerebellar hypothesis of dyslexia, which leads to motor impairment affecting their reading skills, could a specifically structured motor practice improve their reading abilities? To this aim, we chose to focus on the Quadrature motor training, which here, as you see, is a 50 by 50 centimeters square on the floor, in which the participant has to move according to a sequence which is not known to him in advance. It requires both coordination and weighting abilities. So a lot of executive functions. This study was conducted in Bar-Ilan University, in which we compared 8 dyslexic participants to 8 healthy, normal readers. And the participants both trained for 28 consecutive days in the quadrato-motor training, and we measured their cerebellar alpha activity and alpha coherence before and after the training, in addition to a reading task. Here is the experimental design, which you can see. The reading task was a single word reading accuracy and fluency task, in which the participants had to read. The final score was the total of number of correct words read in 30 seconds. Here are different words in Hebrew. And this was the MEG. This is the only MEG in Israel. And we focused on alpha activity, as I said before. So in terms of the results, in terms of the reading, we see that both the control and the dyslexics significantly improved the reading ability in terms of correct number of words read following a month of the quadrato-motor training. And this was accompanied by increased cerebellar activity in the dyslexic group. So these are very novel findings in terms of the cerebellar involvement in dyslexia, and they are in line with the cerebellar hypothesis of dyslexia. We see that, in fact, the baseline alpha activity was lower in the dyslexic compared to the control group, and following 4 weeks of training, the cerebellar alpha activity increased in the dyslexics, and this was accompanied by improved reading in both groups. Now we can enlarge the model and see, until now we spoke about the oscillatory activity leading to improved reading, which could be considered the fast track. But there is also another track which starts with molecular change, which can lead to anatomical changes, also leading to improved cognitive abilities. And we will look at this in the context of additional learning and neurodevelopmental disorders. So neurotrophins play a vital role in this molecular path, and they enhance and allow neuroplasticity. We know that, for example, nerve growth factor and BDNF are two of the most important factors leading to training-induced neuroplasticity. Before showing results in impaired population, let's start with the pilot in healthy adults. And we see again that following 3 months of training, BDNF level can increase also in healthy adults. Here we see the level of pro-BDNF before the training and after 3 months, and they increased in all 3 participants. So this was the first pilot study, and in relation to the cerebellum, we see that this increase in pro-BDNF was in fact related to increased cerebellar volume. Then in recent years, we conducted several case studies. The first one that I'm going to show is of a 20-year-old dyslexic adult, which suffers also from, in addition to developmental dyslexia, also from dysgraphia, and has had very severe symptoms. So we see that we see the severity, and in fact, we see that following 4 weeks of training weren't enough for him to improve his reading abilities, but after 10 weeks of training, he in fact improved his reading, and this was related to also increased BDNF secretion. We see in these results the importance of embodied cognition and of specifically structured sensory motor training, such as the quadrato-motor training, that support the importance of the cerebellum in skilled reading, and they begin to unravel the mechanisms that mediate cerebellar contribution to cognitive and neuronal improvement. Now, we know that the cerebellum on the one side could be considered as an oscillator, and in fact, we showed results related to this, which were related to improved reading, but in parallel, the cerebellum is also related to timing. And now I will show some of the results related to timing abilities and the Quadrature. So the cerebellum is involved both in coordination and timing, and one of the timing paradigms which I will show is called the time production task. And in addition to this, we know that the cerebellum deficits are not only in dyslexia, but also in autism spectrum disorder, and for example, in Asperger. And the severity of the symptomology is related to the severity of the cerebellar deficits. One of the case studies that I'm going to show is specifically related to Asperger, which is in addition related to impaired social abilities. Remember that the cerebellum is also related to timing, right? So timing is in the base both of cognitive, but also of social function in order to know when to approach, how to approach, when to speak, when to respond, and so on. And our hypothesis was that, okay, we know that autism is related to cerebellar deficits, and we know that the Quadrature can enhance cerebellar oscillations in learning disabilities. So could the Quadrature lead to positive outcomes, and could this be related to cerebellar functions? I will show a case study of a 9-year-old boy who suffers from Asperger, who we trained for 2 months, focusing on the time production task. Just to mention the time production task. So we see that in terms of the time production task, it's significantly improved following 2 months of training, in which the participant became slower and more accurate in terms of his time production. And this again supports the linkage between the cerebellum coordination and time productions. There are more results, but I'm going to skip them. And we go directly towards the sum. So I would like to say that following the Quadrature, we see in general increased alpha activity, both in terms of alpha coherence in healthy adults and in terms of cerebellar alpha activity in dyslexics. We know that alpha activity in general is related to improved cognitive performance and to higher states of consciousness. And we see that the Quadrature, as a specifically structured sensory motor training, can increase cognition in terms of reading, creativity, and spatial cognition. And this supports the embodied theories of consciousness. And we can start to suggest that the Quadrature motor training in parallel to other movement meditation can induce the transition from the narrative memory-based there and then self to the more embodied here and now self, which is accompanied by alpha activity. So future studies should examine this and the importance of bodily awareness, divided attention, and also the emotional aspects as possible mediators and modulators that could represent the link between mindful movement, both in healthy development and in developmental disorders. I would like to thank our collaborating institutes and partners and all our collaborators, as science is a team sport. Thank you very much for everyone and for the organizers of this great conference. Be well. Thank you.